Hey physics students, in this video we're going to be talking about the meaning of slope on position versus time graph. So all of this information is related to when we have a position versus time graph. So last time we learned that any position versus time graph that just has a straight line, something like this, we learned that that is indicative of constant velocity. So the velocity is not changing. We also learned that any graph with a curved line, any position versus time graph with a curved line, is indicative of accelerated motion or non-constant velocity. So the big concept to remember from position versus time graphs is that the slope of a position versus time graph is equal to the velocity. So I'll say that one more time. The slope of a position versus time graph is equal to the velocity of the object. I like to remember that with a little saying, as slope goes, so does velocity. So whatever the slope is doing, the velocity is doing the exact same thing. So in here, which of these has the biggest slope? This one right here. I have the steepest slope. It's like climbing up a big mountain. That represents a fast velocity. Compared to this one is like you're walking up a little gentle hill. And this slope is less, and so my velocity would be less. These are both straight lines, meaning that the velocity is not changing. The slope stays the exact same in each of these cases throughout. Therefore, the velocity would remain the exact same as well. Now in this one, is this slope, would we say positive or negative? This example right here, the slope is negative. It's sloping down. As we always look at graphs from left to right. So as we move from the left to the right, we're seeing what our line is doing. If the line is increasing on our y-axis or going up as we move this way, the slope is positive. If, as we move this direction on our position versus time graph, if the y-axis, the values are decreasing, that slope is said to be negative. And so this graph right here represents an object that's moving to the left or in the negative direction. One note on velocity is I can't be going any slower than stopped, than absolutely still. If you have a negative velocity, it doesn't mean I'm going slower than zero. It just means the negative sign out of velocity just means we're moving to the left or in the negative direction. So this is a fast moving object, here's a slow moving object, and these are each moving at a constant velocity. And this right here is going to be a object moving at a medium pace in the negative direction. So let's go ahead. We're going to answer 3 questions for each of these. And you all will be doing this worksheet after we've had a chance to do our balloon car experiment. You all will have already graphed motion of accelerated motion, and we've had a class discussion at this point. So you should at least be somewhat familiar with the shape of graphs and kind of what that graph represents in terms of motion. So this could be review for some of you. If you're struggling with looking at these graphs, that's okay. Hopefully this video will bring some more clarity. And if you're still struggling, please come talk to me in class. I am more than willing to help you. If we don't have enough time in class, reach out to me. We could set up an appointment some other time to get you the information that you need. So 3 questions. If you're feeling confident, you can go ahead and pause the video and answer these 3. If you're still struggling with these concepts, just continue watching along, and I'll walk through each of these examples. But the 3 questions I want each of you to answer are, is the object in each of these graphs speeding up, slowing down, or staying the same, meaning constant velocity? Is the motion of this object, or the velocity, positive, negative, positive or negative? And is the acceleration of each of these objects positive or negative? It could also be 0 in both of these cases. So again, if you're feeling confident, just go ahead and pause the video, try and answer these questions. If you are need a little extra help, then just go ahead and keep watching, and I'll go through these step by step. So, in example A, are we speeding up, slowing down, or at a constant velocity? Well, remember, big concept, the slope is equal to the velocity. So as the slope goes, so does velocity. So let's look and see what our slope is doing. So I got my handy dandy tangent drawing stick. And this stick, what we're going to do is we're going to make a tangent line on the graph. And if you don't know what tangent is, just come talk to me. But basically it is the straight line on a graph at a certain point. And so right here, the slope is almost horizontal. And as we go on, the slope gets bigger and bigger and bigger. And so our slope is increasing or getting bigger. And so our velocity will be getting bigger and bigger. And therefore, we know this object is speeding up. Okay, so this object is speeding up. Now, is the velocity positive or negative? Or 0? Well, we know it's speeding up, so it can't be 0. But again, as the slope goes, so does velocity. Is our slope positive or negative in this case? Well, it's positive because as we move from left to right on the graph, our slope is still, or our numbers on our y-axis, our values are getting bigger and bigger. And so we're going up in the graph, and so our velocity is always going to be positive. And think back a number of lessons ago when we talked about directions of acceleration and velocity. We learned that if an object is speeding up, then the velocity and acceleration point in the same direction. And this is the case here. We have speeding up, my velocity is positive, so my acceleration must be positive. So there we go. That's example A. If that's starting to make sense now, you can pause the video at any time, try the other examples. If you're still confused, just keep watching along. Question B, are we speeding up, slowing down, or constant velocity? Well, what's happening to my slope? That's the first thing I ask myself. And right now, we have a small slope. And we're starting to go downhill, and what's happening to the slope? It's getting steeper and steeper and steeper. And so I know from that my slope is getting bigger, so my velocity must be getting bigger as well. So we are speeding up. Okay, so we're speeding up. Now, is my velocity positive or negative? Well, let's look at what our slope is doing. As we move from left to right, my values are decreasing or going downhill, all right? So, in this case, our velocity is equal to a negative. Our velocity is negative. And because we're speeding up, we can ask our question is, do we have positive or negative acceleration? Well, when we're speeding up, our velocity and acceleration need to point in the same direction. So, acceleration will equal a negative value as well. Awesome. Moving on to C. Speeding up, slowing down, or constant velocity. Well, what's happening to the slope? I'm starting off with a very steep, big slope. And as I move to the right, the slope is getting less and less and less and less until we're horizontal. So I start off with a big slope and I end up with almost a zero slope. So my slope is big to small, therefore we're slowing down. So I'm slowing down. Now we have to ask ourselves, are we moving in the positive or negative direction? Is our velocity positive or negative? Well, as we move to the left to the right, is my slope up like this, or is it down like so? It is up, and our values are getting bigger as we move forward on the x-axis. And so our velocity is positive in this case. However, let's get to number 3 here. Do we have positive or negative acceleration? Well, we're slowing down, which if we remember back, whenever we're slowing down, our velocity and acceleration will point in opposite directions. So we know we're slowing down, we know we have a positive velocity, but because we're slowing down, acceleration points in the opposite direction. My acceleration is going to be negative. All right, one more example to wrap it up. D. Do we have speeding up, slowing down, or constant velocity? Well, we have a straight line on our graph here. So we know that this is going to be a constant slope, or it is a constant slope. It's a straight line, so our slope does not change. Therefore, our velocity does not change. And so when our velocity does not change, we have a constant velocity motion or an acceleration of 0. So no acceleration. No acceleration here. Now, is our velocity positive or negative? Well, as I move from left to right, our values are going downwards. We're going downhill. And so I have a velocity that is negative. And we already said that we don't have any acceleration, so my acceleration will not have a direction. A equals 0. So I hope this has been helpful. I hope you've taken some key things away. Again, I really want you to remember this big concept. For a position versus time graph, slope of a position versus time graph is equal to the velocity. And as slope goes, so does velocity. So on a position versus time graph, whatever the slope is doing, that's what the velocity is doing well. Thanks for learning with me today. Have a great day.